Welcome, my dear friends, to this important lesson rich in important information. Why? Because this lecture can be applied to our future projects. What are the basic tables for managing user permissions? Very, very important. The lecture will be long and will be in two parts. Imagine a busy clinic handling hundreds of patients daily. A receptionist schedules appointments, doctors access medical records, and administrators manage the system. What would happen if a receptionist accidentally accessed sensitive patient information or a doctor modified financial records? To solve such challenges, we implement role-based access control, RBAC, where users have access only to the data and functionality appropriate to their role. By the end of this lecture, you'll be able to design and implement a secure RBAC system to ensure privacy, data integrity, and efficient clinic operations. Learning objectives. By the end of this lecture, you will 1. Understand the importance of RBAC in securing applications. 2. Design comprehensive models for users, roles, and permissions. 3. Configure database relationships and constraints effectively. 4. Apply migrations to update the database schema. 5. Analyze the purpose and benefits of modular RBAC components. 6. Evaluate the system's structure and scalability. Lecture plan. Step 1. Introduction to RBAC concepts with a practical example. Step 2. Detailed database design. 1. User table. 2. Role table. 3. Permission table. 4. User role table. 5. Role permission table. Step 3. Configurations. Building precise relationships for RBAC. Step 4. DB context integration. Applying modular configurations. Step 5. Migrations. Generating and applying schema updates. Step 6. Conclusion and evaluation. Step 7. Preview of the next lecture. Let's do their steps. Step 1. Design classes for user management with detailed explanation. Here, we want to understand something very, very important, which is the relationship between these user management tables. Of course, these tables will be in almost every system in managing user permissions, so they are very important. So we must understand the relationship between the user management tables well. The role-based access control, RBAC, system consists of 5 interconnected tables: user, role, permission, user role, and role permission. These relationships ensure secure role-specific access to system functionalities. On user and role many-to-many relationship. Explanation: a single user can have multiple roles, example, admin and doctor, and a single role can be assigned to multiple users. Intermediate table, user role acts as a bridge to connect user and role. Example: user John Smith. Roles: doctor, administrator. The user role table will have 2 entries. User ID, role ID, an doctor. 1 do admin. 2. Role and permission, many-to-many relationship. Explanation: a role example. Doctor can have multiple permissions and a single permission, example. View records can be shared by multiple roles. Intermediate table. Role permission connects role and permission. Example: role doctor. Permissions: view patient records, edit patient notes. The role permission table will have two entries. Role ID, permission ID. One doctor, one view. Doctor, edit. 3. User and permissions indirect relationship. Explanation. A user gains permissions indirectly through their assigned roles. Flow. User, user role. Role, role permission, permission. Example. User John Smith. User ID. Role, Dr. Role ID. 1. Permissions. View patient records. Edit patient notes. John Smith can now view and edit patient records without directly linking to the permission table. Summary of relationships. User between role. Many-to-many through user role. Role between permission. Many-to-many through role permission. User between permission. Indirectly linked through user role and role permission. I hope my explanation is clear. You must understand this relationship well. We will create a class called user. This class, to purpose, stores user information such as login credentials and contact details. Public class user. It will contain the following features. Public integer. User ID gets set. Primary key ensures that every user is uniquely identified. Public string username gets set. Unique username for login. Public string password hash gets set. Hashed password for security. Public string full name gets set. Full name of the user. Public string email gets set. Email address for notifications. Public string phone number gets set. Contact number for communication. Public bool is active gets set. Account activation status provides flexibility to temporary permissions. Public class role permission. Public integer. Role ID gets set. Foreign key for role. Public integer. Permission ID gets set. Foreign key for permission. Navigation properties. Public role roles get set. Associated role. Public permission get set. Associated permission. Now, if we go back to the permission table, the problem will disappear because it found our argument role permission and refers to it. Also, the table has two properties that refer to the role table and the role table. Why? So that the relationship between them is complete. Our goal is to create a table in the database called roles that contains the following columns. Role ID, integer, links to the role table. Permission ID, integer, links to the permission table. Step 2. Configuring relationships. The complete set of configurations for all the tables. User, role, permission, user, role, role, permission. Each configuration ensures the database relationships, constraints, and indexes are applied accurately. So, we will create a class in the configuration folder called user configuration. for purpose defines the constraints and relationships for the user table. Here, user ID primary key. Here, username ensure. Username is required and unique. Here, password must be provided. Here, full name is required and has max length 200. Here, email with length 250 characters and optional email for recovery. Here, the phone number with max length 15 characters and optional phone number here is active default to active user. Enforce unique usernames. The purpose of user configuration ensures each user has a unique username to prevent login conflicts. Enforces constraints like required fields, password hash, and maximum lengths for user data. Adds an index on username for faster searches. And we will create another class in the configuration folder called role configuration. Defines the structure for the role table. Role ID primary key. Here, role name must be unique and required and has max length 50. Here, description has max length 500 and optional description for clarity. The purpose of role configuration defines the structure of the role table, including a maximum length for role names. Provides optional descriptions for better documentation of roles. And we will create another class in the configuration folder called permission configuration. Defines the structure and constraints for the permission table. Here, permission ID is primary key. Here, permission name is required and has max length 100. Here, description has max length 250 and optional description for clarity. The purpose of permission configuration sets up unique and required fields for permissions. Allows administrators to understand the purpose of each permission. And we will create another class in the configuration folder called user role configuration. Defines the many-to-many relationship between the user and role table. By going to the database and making sure of that, oh my, very good. The new tables have been created successfully. Step 5. Conclusion. In this session, we established a secure and scalable foundation for the clinic management system through role-based access control, RBAC, by designing structured models, configuring precise relationships, and applying migrations. We ensured that users interact with the system according to their roles, safeguarding sensitive data while enhancing efficiency. RBAC is more than access control. It's about enabling seamless evaluation for the lecture. What is the purpose of RBAC and how does it enhance system security? Why are user role and role permission tables essential for managing relationships? Preview of the next lecture. Next session, we'll introduce site settings and notifications, enabling administrators to dynamically update system settings like enabling maintenance mode and send targeted alerts. Example, notifying doctors of urgent updates. These features will enhance flexibility, efficiency, and communication within the clinic. Stay tuned for this exciting upgrade. I hope my explanation is clear and understandable. We hope you understand well. See you in the next lecture. Goodbye.